Hello everyone, I hope that everyone is doing very well. Here I'm Suraj, and in this video I'll be showing you how we can do independent t-test by using the SPSS software. In the previous videos I have already discussed the other type of the t-test, like the one sample t-test, how we can do one sample t-test by using the SPSS software, how we can do paired sample, or we can say dependent sample test t-test by using the SPSS software. Okay, so in the previous videos I have already discussed about this two, one sample and the dependent t-test. Okay, so if you have not watched this video, you can watch this video. I'll share the link at the description box. Okay, so in the one sample t-test I have said that when we are comparing the same thing of the two groups, then we can use the one sample t-test. Means if I want to compare the mean of my respondent with the known mean of the populations, then only we can use the one sample t-test. I have given an example, right? The mean of the height of my respondent with the mean of the population in India. So I want to know that whether my respondents are taller or the shorter than the national average, then only we can use the one sample t-test. But in case of the dependent or paired sample t-test, we should have to take only one group, but we will compare the mean of the two different observation of the same group. I have given an example like I want to measure that whether there has an impact of the morning walk in the blood pressure or not. So for that I will collect the information. I will collect the blood pressure before morning walk of the respondent, and I will collect the blood pressure after morning walk of the respondent. Then I will compare that whether two means are significantly different or not. Okay, so if we are comparing the mean of the two observation of the two same groups, then only we can use the dependent t-test. And another example, I have said that I have collected I have collected the scores of the students before intervention of a teaching procedure. Okay, and I have also collected the scores of the after intervention of the teaching procedure. Whether I want to know that, I want to measure that whether this teaching intervention has really impacted on the marks of the students or not. Then how we can measure, how we can say that yes, this teaching intervention has an effect, this teaching intervention has impacted on the score of the marks. By using the dependent t-test, we can say that yes, these two main of the two observation has significantly difference, and how much they are differ from each other, that can also be measured by using the paired sample t-test. But here in this video I will especially I will discuss on how we can, I will show you on how we can do independent t-test by using the SPSS. So but the question is, when we can do independent t-test? See, in case of the survey research, when we are comparing the mean of the two independent group, when we are comparing the mean of the two independent group, then we can use the independent t-test. In case of the one sample t-test, we are comparing the mean of the two groups. Okay, one mean should be known. Okay, and in case of the dependent t-test, we are comparing the mean of the two observations of the same group. There should be one group in case of the dependent t-test, but in case of the independent t-test, there should be two independent group. Okay, so if we are comparing the mean of the two independent group, then only we can use the independent t-test. So let's go to the SPSS. I will tell you how we can calculate, how we can use, how we can do independent t-test by using the SPSS. So let's go to the SPSS. So here you can see that I have opened the SPSS software. Okay, so here you can see that I have also put the data at the SPSS software. So if you want to put up this data in your SPSS software, you can pause the video and you can put up this. Okay, so this data set I will use for the independent t-test. Okay, so I have already said that when we are doing the independent t-test, there must be two independent groups. So we at the independent t-test will compare the mean of the two independent group. Okay, so here in the data view you can see that I have given 1 2 2 2 1 1 1 2. Okay, that means I have here mentioned the two independent group at the numerical form. Okay, suppose in this data set I have used one independent group as male and one independent group as female, and I have here written I have their height. Okay, I have their height in inch. Okay, so here one will represent female and two will represent male. So how I will show you how we can write one will represent male and one will represent female at the variable b. Okay, so independent t-test, or we can say simple t-test, or we can also say student t-test. Okay, so the main thing is that we are comparing the mean of the two independent group. Okay, so here one group is male and one group is female, and we will compare. We'll see that the mean of the male is, or the mean of the female is statistically significant from the another mean or not. Okay, mean of the one independent group is statistically significant from the another group or not, by using the one sample t-test, by using the by using the independent t-test, we can measure that. So how we can analyze it, I will show you in this video. Okay, so now go to the variable view. Just give here, you can see that the name of the first one is that gender. I have said that the male and female. Okay, so I'll write gender here. Okay, so I have said that one will represent female and two will represent male, so we'll have to write that. Okay, so now go to the value options, click on that. Now give the value 1. Value 1 will represent, okay, 1 minute. Okay, value 1 will represent female, so I will write female here. Click on add, and value 2 will represent male, so I will write male here. Click add and click on the OK button. Okay, so since our gender male and female is categorical variable, we'll click on the nominal data. It is nominal data, categorical variable. Okay, and the second option is there. I have written, you can see that here, this is height in inch, so I'll write height here. And data is in scale form, so I'll click on the scale. Okay, by default it is here, and scale is there. Okay, now for the analysis, what we can do now, after doing that, we'll have to go to the analyze. Just go to the analyze, go to the compare means. Okay, then go to the independent sample t-test. Click on the independent sample t-test. Now this dialog box will come. This dialog box will come like that. Okay, this dialog box will come. Now what we can do from there? Okay, now here you can see that gender and height. So we are comparing the height, right? So our test variable will be height. So click on the height, click on this arrow mark. Okay, now our grouping variable is gender, right? Male and female. So I will click on the gender and I will click on that. Okay, so our grouping variable is gender. Now you can see that one question mark is there. So what we'll have to do, to just click on the define groups, and group 1, you can see that by default it has come. If it is not there, you can write that group 1, just click one, just write 1, and group 2 just write 2. Okay, so by default it has come 1 and 2. Okay, just click on the continue. Okay, now click on the option, you can see that 95% confidence interval, 95%. By default it has come 95%. You can change the confidence interval also. Okay, so I am not going to change the confidence interval now, so just click on the continue. Okay, now click on the OK. Okay, so here you can see that output has come right here. This is the descriptive statistics and this is the independent statistics. Okay, so here in this box, from this box we can see that our male respondents are 7 and the female respondents are 5. Okay, and the mean height of the female respondent 7 and the male respondent 5, and the mean height of the female 67 inch and the mean height of the male 64 inch. Okay, here you can see the standard deviations and the standard error of mean. Now you can see by looking at, this is the inferential statistics box. So by looking at this box, okay, we can measure, we can indicate that whether the mean of the one independent group is significantly different from the another independent group or not. But here you can see that there are the two rows. Okay, one is equal variance assumed and equal variance not assumed. But when we are doing the one sample t-test, in the one sample t-test we have seen that there are only one row, right? In the dependent t-test also there are only one row, but in the independent t-test you can see that there are two rows. So how we can choose
which row we should have to take for measuring the significant difference of the two mean of the two independent group. So by looking at the Levin's test of equality of the variance, we will choose which row we should have to take for measuring the significant difference of the two mean. Okay, so how we can indicate that? So by looking at the p-value of the Levin test of equality of the variances. Okay, so Levin test of equality of variances means actually what we assume at the independent sample t-test. The assumption of the independent t-test is that two groups we are comparing here, right, have a similar dispersion of score, whether data of the both groups have equal variance or not. Means variance, how much data are spread from its mean value. Okay, so here we can formulate the null hypothesis that at the Levin's test of equality, that our assumption is true, means equal variance of equal variance assumed. Okay, means our assumption is true, means assumption of independent t-test is that we are comparing the two groups where the similar dispersion of the score are there, means the distribution of the data, the spread of the data is equally, homogeneity is there. Okay, so by looking at the p-value at Levin's test of equality of variance, we can choose that which row we should follow for determining for measuring the significance difference of the two means. Okay, so here you can see that the p-value is 0.024. so we know that if the p-value is more than 0.05, we accept the null hypothesis, right? So that means our assumption is true. That means there equal variance is there. So equal variance is assumed. We will choose the equal variance assumed row. If the p-value is less than 0.05, will reject the null hypothesis and we will say that our assumption is wrong, means we will choose this row. Okay, so here our p-value is larger than the 0.05, we'll say that our assumption is true and we'll choose the first row. Okay, here equal variance of assumed. Okay, now looking at the t-test equality of means, we can measure, we can indicate that the significance levels of the, whether there is a significance difference between the two means or not. So I have in the previous videos I have already discussed that by looking at the three ways we can measure that whether two means are significantly different from the each other or not. Okay, so first method is by looking at the t-value. By looking at the t-value, we can measure that whether the two means are significantly different or not. Okay, so here you can see that what our calculated t-value is 1.928. Okay, 1.928 is the calculated t-value, but we know that if the calculated t-value is larger than the critical t-value, we'll have to see the critical t-table. Okay, so if the calculated t-value is larger than the critical t-value, will reject the null hypothesis. Okay, we'll reject the null hypothesis and we'll say that there has a significant difference between two means. Okay, between the two mean. Okay, here we can see that the calculated t-value is 1.928. now we'll see that the at 10 degree of freedom, what is the critical t-value? Okay, so here you can see that at the 10 degree of freedom, 5% level of significance, critical t-value is 2.228. That means our calculated t-value is smaller than the critical t-value, right? So we will accept the null hypothesis. We will accept the null hypothesis and we will say that there has no significant difference between the two means. And another option, another method is that by looking at the p-value. Here you can see that p-value is 0.083. So if the p-value is smaller than the 0.05, if the p-value is smaller than the 0.05, we reject the null hypothesis. But here the p-value is 0.83, which is greater than the 0.05. So we accept the null hypothesis and we'll say that there has no significant difference between the two means of the two independent group. Okay, and another method is by looking at the 95% confidence interval. Okay, so here you can see that the lower value of the confidence interval is in the negative, okay, and the upper value is in the positive. But how we can indicate that? Okay, so 95% confidence interval includes zero. Okay, so if zero includes in the interval, that means we will say that we will accept the null hypothesis. Here you can see that one is in the negative value and another is positive value. So here zero includes in that interval. So we'll say that we'll accept the null hypothesis. That means there has no significant difference between the mean of the two independent groups. So by looking at this three way, we can say that there has no significant difference between the means of the there is no significant difference between the two means. Okay, so this is about this video. I hope that you have understood and how we can do independent t-test. Okay, so if you want to watch the dependent t-test and one sample t-test, you can watch this. I will share the link at the description box. Thank you so much.